If we go the other way, you might ask, how do I find the equation of the line from the graph? Well, let's see a few examples of that. If I look at graph 1 here, I have a y-intercept of 4. That's going to be my b value right there. And I have a slope. Looking at it, I go down 1, 2, 3, 4, and over to the right 1, 2, 3. So that's a change in 4 on the y and a change in 3 on the x. It's actually negative 4 on the y because we're going down to the right. So that's going to be a negative slope. Okay, so my slope is minus 4 thirds y equals minus 4 thirds x plus my b value, which is 4, plus 4. That is the equation of this line shown in the graph in y equals mx plus b format. Let's look at number 2. Y equals mx plus b. And I can see my intercept is at 0, so b equals 0. And my slope, again, it's negative. And I'm going down, it looks like 5 downward to go across 3 in x. So y equals minus 5 thirds x plus 0, or that's just simply the equation of the line shown. Let's see a couple others. Number 3, our y-intercept is plus 2. And we're not exactly going through negative 1 there, so be careful. It looks like the next point that lies on the corner of a grid is y minus 4, x negative 2, which means we're going down 6 to go left 2. That means my slope is going to be 6 divided by 2. So y equals 6 divided by 2. That's my slope. Positives, upward to the right, x plus r2, which is our y-intercept. Or stated another way or simplified, y equals 3x plus 2 is that line right there. The next one, our b value is 0, 3, so b equals 3. And our slope, again, a good crossing point looks to be right there. So it looks like we're going over 1, 2, 3 in x direction to go up 1, 2, 3, 4, 5 in the y direction, which means our slope is going to be 5 thirds. Y equals 5 thirds x plus 3. And that is the equation of that line. What if, on the other hand, I had a line that kind of looked like, say, something like this? Try and draw it a little more accurately here. And I see I cross a point there and a point there on the 2 grid line corners. But I don't see any y-intercept. Up to now, we used our y-intercept as the first point. I have no y-intercept. I can see the slope of the line. It's positive, going upward to the right. Okay. And I'm going over 2 in x to go up 2, 4, 6, 8, 9 in y. So my slope, which equals my delta y over the delta x, is 9 up to go 2 to the right. It's 9 halves. So I have the following for my equation. Y equals 9 halves x plus b. But I don't see the b or the y-intercept on the graph. What do I do? Well, conceptually, we can do the very same thing we did when we found the equation of the line in the first place. If I have an xy point that's on the graph, I can plug that in and derive the value of b. I do have that. If I look over 1, 2, 3, 4, comma, over 4, my point there is 4, comma, 4. I'm going to plug that back in for my x and my y, and I'm going to solve for b. So what does that work out to? That's going to be 4 equals 9 halves times 4 plus b. 4 equals 9 times 2, or 18, plus b. Subtract 18 from both sides. B equals minus 14. Does that make sense? Let's do a quick common sense check. My b is going to be much lower than sort of negative 5. It's going to be way down there, maybe down here where it actually crosses my axis. So negative 14 makes sense. My final equation is y equals 9 halves x minus 14. That's the equation of the line, and I did it without seeing the y-intercept on the graph, so you should be able to do the same.